All right, and then there were the proofs, the verifying. This is going to be the main focus of your test, obviously, being able to show step by step how one side equals the other. Remember, you can't treat this as an equation. So looking at this particular problem, there's two routes you can take. You can either work with the left side or the right side, and either way I think is going to be just as much work. And it's going to involve factoring probably one way or the other. So I was thinking maybe the left side, just kind of off-center that. 1 minus cotangent to the fourth is the difference of squares. So I was thinking 1 plus cotangent squared x times 1 minus cotangent squared x. Now I notice 1 plus cotangent squared x, that is cosecant squared x. That is an exact identity. Now this 1 minus cotangent squared, what we can do, let's write this first. We write 1 minus cotangent squared. At least we're dealing with cosecants here. Now, I could write a cotangent squared as a cosecant, but I have to kind of work with the formula. The formula being that, well, 1 plus cotangent squared, that is cosecant squared. So therefore, if I were to subtract cotangent squared from both sides and subtract cosecant squared, if you follow what I just said, I would get this statement, that negative cotangent squared x is really 1 minus cosecant squared. So using that substitution, I would say we have cosecant squared x still on the outside to be distributed, and then we have 1, and then that will be plus 1 minus cosecant squared x. Right. And then 1 plus 1 is obviously 2. I'll distribute. So 2 minus cosecant squared. When you distribute, you'll get 2 cosecant squared x minus cosecant to the fourth. Got nervous there for a second. Cosecant to the fourth x, which is what we had to prove. So, this step right here, oops, from here to here, you do have to justify it with this formula. But that's what I used. I kind of moved some terms around left and right side to get what I wanted for my substitution. Now, you could have taken this the other direction. If you factor out a cosecant squared, and then you would get an identity that would be, or could be replaced with a cotangent squared, and you can arrive at the other side as well. So both methods should be pretty legitimate. All right. Second one. Where's my blue? There's B. We got 1 plus sine of x over the sine of x. We have to verify that that equals cotangent squared. Cotangent squared x over cosecant of x minus 1. All right, looking at this particular problem, I'm thinking the right side would be the side I'd probably want to work with. There's more to do over here. Here on the left side, maybe you want to try the Hart method. It's just, don't expect it to give you this. It's not going to, but maybe after we simplify this a little, we might end up with something like that. So let's leave that on the back burner. All right, what do I want here? Well, notice this cotangent squared. Cotangent squared, if you look from the last problem, we can use this particular identity. Now, we need a 1 plus cotangent squared. That's cosecant squared. But if you take this and subtract a 1 from both sides, we can call cotangent squared cosecant squared minus 1. Now we have to justify that. Cosecant squared x minus 1 over cosecant x minus 1. Right? We have to justify that by saying, okay, 1 plus cotangent squared x equals cosecant squared x. Right, so justified. Again, it's not the exact identity, so we do have to justify how we got from here to here. Now, do not think we're canceling yet. We cannot. But if we factor that numerator, it is the difference of squares. It's cosecant of x plus 1, cosecant of x minus 1. This is over cosecant x minus 1. And now we are allowed to cancel common factors, which we do. We're left with, well, cosecant x plus 1. Now, we could write this as 1 over sine, get common denominators, and produce this. But I'm thinking, why don't we just stop here with this right side and work with the left side, do the heart method like we were originally thinking. This is a little bit easier path, I think. Right? So we don't have to get common denominators. We're actually separating these into two fractions. 1 over sine, well, that's cosecant. Sine over sine, well, that's 1, and that should work. All right, let's see if we can't sneak another one in this video. Letter C. Here we go. Let's see. Letter C. Where'd you go? Letter C. We got secant theta plus 1 over tangent of theta equals tangent of theta over secant of theta minus 1. So this is letter C. All right. Yeah, what do we got here? Looks like a mess. What to do with this? Well, this might be one of those where we got to work with both sides again. I'm thinking maybe sines over cosines. Just my first thought. So we'll write secant as 1 over cosine plus 1, just using my reciprocal identities. Now, tangent, I'm not using the reciprocal identity, I'm using the quotient identity. So tangent is sine over cosine. All right. Complex fraction, multiply top and bottom by the LCD, which is just going to be cosine. And let's see what we get here. We'll distribute the cosine through in the numerator. So 1 over cosine times cosine will just be 1. 1 times cosine is cosine. Denominator, cosine times sine over cosine. Cosines cancel. Just have those sine. I guess that's decent. We'll stop there, see what we get on the right side by doing the same thing. So quotient identity, sine over cosine. Secant, we'll call it 1 over cosine, reciprocal identity. Multiply by the LCD. Numerator gives us what? Sine theta. Denominator, we have to distribute that. We'll distribute cosine to 1 over cosine. This gives us 1. And then negative 1 times cosine is negative cosine. All right, unfortunately, those aren't matching. So what we're going to do, I'm thinking on either this one, we can multiply top and bottom by this conjugate, or multiply top and bottom by that conjugate. And then I'm going to keep working with the right side. So I'm going to multiply by 1 plus cosine theta. And this little trick, what I know that's going to produce, it's going to produce 1 minus cosine squared in the denominator, which is sine squared, which eventually down the road will cancel some stuff out here. So sine of theta, since we're looking to cancel stuff, don't distribute. Don't distribute it through the numerator. Keep it undistributed, otherwise you're going to have to factor it right back out. Now the denominator is just 1 minus cosine squared. All right, I am out of room. So I'm continuing with this one. We'll bring it up here. Sine of theta in the numerator. 1 plus, that's not good. 1 plus cosine theta over, I'm going to call 1 minus cosine squared sine squared. And I do have to justify that. So sine squared, let's go with the variable, cosine squared equals 1. That's our justification. And then we can cancel 1 factor of sine with 1 factor of sine, leaving me with 1 plus cosine over sine. Let's hope that's the left side. Yep. And